Hi guys, so I'm at a meeting today, but I wanted to make sure we got through the other two tests. So I'm going to go through number 2. It says the data on drinking behavior for independently chosen random samples of male and female college students is given below. The data comes from a study done in the Journal of College Student Development, as there appear to be a gender difference with respect to drinking behavior. So when we're looking at tests for homogeneity and independence, they're different than goodness of fit, because goodness of fit looks at one sample compared to a norm. And here we're comparing two pieces of our sample, males and females, and then their drinking levels. So we're looking at two variables within our sample, gender and drinking level. This is a test of homogeneity because it's looking to see if there's any difference within our gender. So our hypotheses are similar to a goodness of fit test. My null hypothesis is there is no difference in gender with respect to drinking behavior. And my alternative is that there is a difference in gender with respect to drinking behavior. Our conditions are the same. We have counted data. And my counted data, I said they counted drinking levels for each gender. Randomization. It is stated that it's a random sample. Of 2017 males and females. And then we have the expected cell frequency. So, before for goodness of fit, when we're finding our expected cell counts, we use the norms, but there are no norms here. So we have to use something different to find our expected counts, right? And if you took the notes, you'll see how we find our expected count if we take the row total times the column total all over the grand total. So for example, if I wanted to find the expected counts for males who don't drink, I would look at the male total, 981. I would look at the non-total, the 326, and I would multiply those. I would take 981 times 326, and then I would divide it by the grand total, the 2017. So that gives me about 158.6. So again, if I do another example, if I wanted to find out the expected counts for males who have low drinking levels, I would take the column total, so 981 for males, times the row total, so the 1139, divided by the grand total, so 2017. And I get 554. So if I continue that process, I would get 230.1, 38.4, 167.4, 585, 242.9, and 40.6. So all of my expected counts are above 5. So all expected counts, and that's in the table above, are at least 5. So my conditions are met. So I can use a chi-square distribution with, and we're going to talk about degrees of freedom in a second, to perform a chi-square test for homogeneity. Okay, so my degrees of freedom. My degrees of freedom are a little bit different for tests of homogeneity than goodness of fit. I find the degrees of freedom if I take the number of rows minus 1 times the number of columns minus 1. When you do this, you do not include totals. So if I look at my table, I have 4 rows and 2 columns. So I'm doing my rows, I'm taking 4 minus 1. My columns, I'm taking 2 minus 1. So that gives me 3 times 1, or 3 degrees of freedom. So from here, I'm ready to do my mechanics. Just like goodness of fit, I need to draw the chi-square model. I need to write out my formula. And I need to find my p-value. So I'm going to do this all in the calculator. In my calculator, I can't put this into lists and spreadsheets because it's not just rows or just columns. There's 4 rows and 2 columns. So I'm actually going to use a matrix. So I am going to make a matrix. Okay, so you can make a matrix in a couple of different ways. I'm just going to go to Menu, Matrix and Vector, and I'm going to create a matrix. And this is a 4, because there's 4 rows, by 2 matrix. And I'm going to put in all of the observed counts. So the 140, 186, 554, 585, 230.1. Oh, that was, sorry, I was starting to do expected. These should be all observed. 478, that should be 661, 300, 173, 63, and 16. And then I'm going to store this as a variable. So how we store things, where that var is above the 9, if I hit Control, var, it gives me a little arrow and it can store it as a variable. So I'm just going to store it as A. Now I'm going to run the test. So you don't have to put the expected counts in, you just have to put the observed. If I hit Menu, Statistics, so 6, Stat Test 7, there's another chi-square test. It's a 2-way test. So I know it doesn't say homogeneity, but this is the one you pick. And it's going to ask you for your observed matrix, which is A. I'm going to click OK. And look, there's my chi-squared statistic, and there's my p-value. So, my chi-squared statistic is 96.526. And that leads me to a p-value that's approximately 0. So I'm going to go ahead and just shade my chi-squared statistic. So I'm going to go ahead and write out my conclusion. My p-value is below an alpha of 0.05, so it's low, thus I reject a null hypothesis. There is evidence of a gender difference with respect to drinking behavior. So I do now have to give an example because I rejected the null. In my calculator, you can see, just like before, we have this comp matrix, and that will give you the individual computations for that chi-squared statistic. So if I hit var, and I find the comp matrix, and hit enter, and enter again, I look for the two biggest numbers. So the two biggest numbers are the 21 and the 20. So if you go back to your two-way table, that represents this right here, because it was the third row, first and second column. So you can see that more males were moderate drinkers than expected, less females were moderate drinkers than expected. So I'm just going to write that out. So for example, more males and less females were moderate drinkers than expected. Now, the next one, I'm not going to go all the way through the next one, but the next one, this, if you read through the problem, the question asks, using the data collected, is there an association between TB viewing and cardiovascular fitness? Anytime you see the word, is there an association, this is going to be a test for independence. And the nice thing is the test for homogeneity and the test for independence are exactly the same, except for the hypotheses. So my null hypothesis is there is no association between TV viewing and cardiovascular fitness. And then the alternative is there is an association between TV viewing and cardio fitness. So I'm not going to give you guys to actually try this one, but I'll leave an answer key so you can see that you run it exactly like you run a test for homogeneity. The only difference were the hypotheses. All right, good luck. I'll be back tomorrow after I'm done with my meeting to help you guys if you need any help.